Hello and a warm welcome to everyone joining us today. I hope you're having a fantastic day so far. Today we'll be presenting an overview of DDI Central's features and functionalities tailored specifically for Linux-based ecosystems. Whether you're managing bind DNS, ISC DHCP, or any Linux native services, this session will show you how DDI Central integrates seamlessly to deliver centralized management, automation, and visibility into your core network services. Before we move into the presentation, I'd like you to confirm in the webinar chat panel if you could hear me and see the presentation. And that being said, you can shoot out your questions in the webinar chat panel. Our team would be able to give you prompt answers. You can also post your questions at the end of the session if you'd like me to answer your questions live. So what is ManageEngine DDI Central? DDI Central is a full stack DNS, DHCP, and IP address management platform built for on-premises DNS DHCP clusters. So it basically discovers your DNS and local and remote DNS and DHCP clusters and aggregates all those configurations into a unified console and helps you manage it through a single console. What does it manage? It manages all your local and remote Linux-based DNS and DHCP clusters, Microsoft-based DNS and DHCP clusters, and we also have multi-vendor integrations with AWS, Microsoft Azure, Google Cloud, and Cloudflare. So it helps you to visualize, automate, and analyze and control your configurations through a unified console. So basically with this local DNS and DHCP, it helps you discover the configurations, consolidate them, and centralize those configurations. And you'll be able to easily establish a plane of control for these configurations. For the remote-based DNS and DHCP clusters, we require you to make these remote DNS and DHCP clusters to be accessible for the central console. So we have something called the management UI console, which is the central server through which these remote clusters should be made accessible. It could be made accessible using private networks connected through IP MPLS code augmented by a VPN or point-to-point connections or SD-WANs. So you should make all those remote clusters accessible to the DDI Central console, and with those clusters connected to it, DDI Central will be able to effectively manage these remote DNS and DHCP clusters. Let's quickly dive into the DDI Central architecture. It has got two components, as I told you before. The management UI console, which is the central server through which you'll be able to have a unified visibility of your local and remote DNS and DHCP clusters. So the Discovery Node Agent is a lightweight software that has to be deployed on all your onboarded DNS and DHCP servers. Only with this Discovery Node Agent will these servers be able to communicate with the central server, and the central server will be able to make changes. So it will frequently communicate with these servers, and it can push over all those all those configurations that you make via the central console, management UI console, and it will be able to communicate with the onboarded servers. The another major thing about the Linux-based installation is that with a Linux-based installation, say so there are two installables available. So with these two installables, you'll be able to discover and manage both Linux-based DNS and DHCP clusters as well as Windows-based DNS and DHCP clusters. So in case if you take this Windows, we only offer you an EHC-based installation. But if you take the Linux-based installation, we offer you the provision. You'll be able to manage both Linux as well as Windows. So that's an added advantage. We specifically designed this EHC-based installation just to discover and manage the Windows-based DNS and DHCP clusters. So you can only, it is only limited to Windows servers, but the Linux can universally manage both Windows and Linux, and you can have a unified visibility in and control over these local and remote Windows as well as Linux based clusters. So that's about the architecture. And even if you're moving out from a particular appliance based software like Efficient IP or Infoblocks, you would require to provide us, you would be providing us physical servers, like we are a software-based solution. So we would need certain servers from your side. So any Linux-based server would do. So you'll be provisioning these physical servers, or as a virtual machines. They should be hardened, they should have hardened Linux OS running in them. So with those configurations, we'll be able to manage your existing servers. So we will function, DDI Central will function as an overlay over your existing Linux based servers. So we have DNS and DHCP server software built in with our installations. So even if you onboard any Linux based server, we'll be able to install the DNS and DHCP server software along with our management UI console and discovery node agent. So you need not worry about the server softwares, DNS and DHCP server softwares. The DNS and DHCP server softwares come along with the DDI Central installations. So all you have to do is onboard any Linux-based servers. That will do. So based on the sites you manage, you'll have to decide the number of, DDI Central follows a cluster-based modular architecture. So you'll first have to decide the number of sites that you're going to manage. And based on that, you'll have to create as many number of clusters. So for example, if you're managing, if you're managing 5 sites, for example, you'll have to create 5 clusters in DDI Central. So with each cluster you create its own space, like IP address space, its own IP address manager, DNS manager. So for each cluster you create, it has got its own internalized components coming along with it. And if you're managing even overlapping IP address space for a single facility, say you have a certain branch office and you have multiple DNS and DHCP servers, in that case, you'll have to onboard each cluster. If you'd like to manage different IP address spaces for the same site, you'll have to deploy each DHCP server that you like to separate into separate clusters. So you can onboard each DHCP server into separate clusters and manage separate IP address spaces for the same facility. This way, overlapping IP address spaces will be created, but there will be no problem of IP address conflicts. So there will be total independence from the address spaces being colliding with each other. So they'll be logically separated and they'll be independently managed for the same site. So as you can see, for the cluster you create, it has got its own IP address manager, DNS manager, DHCP manager, and its own IP address, dual stack IP address space, global DNS and DHCP configurations, and everything. So this will be, these are the components of a cluster. So when we onboard the servers altogether, we onboard it on a certain order. So based on that, each server will have its incumbent global configurations. These global configurations are nothing but global standalone DNS DHCP options. So when these servers are clubbed together in a cluster, and when they are sharing a unified visibility through DDI Central, we'll have to combine these configurations in such a way that DDI Central, when viewed through DDI Central UI, you'll be able to see all the configurations all together. So basically what DDI Central does is it aggregates the configurations from these servers, and it gives you a unified visibility. So for a single valued, if there is a list of configurations, list of values, so it'll aggregate the configurations. But if it is a single valued setting or a configuration, say for example, if you have certain DHCP option or custom option, in that case, the options that bear single values should be taken from the latest onboarded server. Say if the servers are onboarded in certain order, server A, server B, server C, the servers will be on the latest onboarded servers configuration will be taken as the configuration of the cluster. So if you have certain overlapping options, for example, the same option defined in 3 servers, the value of the option of the latest onboarded server will be taken into account as the value of the whole cluster. So that's how the global configurations are aggregated and viewed through DDI, applied through DDI Central clusters. So let's see how the clusters are created. So we have an interactive demo up and running for you. So you can just get into this console and you'll find the add cluster button over here. Just click on it and you'll get to see the create cluster window. Here you'll name the cluster and select the type of the cluster based on the operating ecosystem that you're operating, be it Linux. So in case if you're managing Linux-based ecosystem, choose Linux. And for the service type, you'll be choosing what services will be running in that cluster, whether it's going to be purely DNS or purely DHCP, or both the services combined together running in that cluster. So based on the type of the service chosen, the cluster will be created. And in this case, you can choose both and you can create the cluster. And then once the cluster is created, you'll be automatically prompted to onboard your servers. So you'll be immediately taken to this page, which is the add server page, where you'll enter the server name, server type, whether it's going to be a DNS or DHCP server or running the server that runs both the services together. And then you'll feed in all the port information, and you'll tell DDI Central whether you want to discover the configurations from the server. So if you're onboarding any Linux-based server with no DNS or DNS server software installed, you can just skip the discover part. And you can just onboard the servers by giving the app console details, and you can save the configuration. So basically, it just onboards the server, installs the DNS and DHCP server software, and then it acts as an overlay. So whatever configuration that you make via the UI will be permanently written into the server. So in case you want to discover the existing configuration, suppose if you have an active DNS and DHCP server software, and you want DDI Central to discover it, you can choose the discovery option. Based on the volume of the configurations, the discovery process will take time. And once the server is subjected to the discovery process, it will discover all the configurations and list it out in the respective modules. So that's about the server onboarding. Once you are done with server onboarding, you can see all the server details right over here. You can see its live logs, especially this is meant for DHCPD service, and you can export the logs to a central, to an external server. You can choose the type of the service logs that you would like to export, and then you can save the configuration. Basically, it centralizes, consolidates, and exports the logs to an external server. And then you can view key system metrics like disk usage, memory usage, CPU usage, so that you can effectively monitor your servers that are onboarded into a particular cluster. And then you can flush the DNS cache, or you can eject the server from DDI Central application. So once the servers are added, you can establish a HA configuration for your servers. So for this, you'll have to enter the primary and the secondary. So HA configuration is basically setting up two servers in a HA relationship or high availability relationship. So you'll have a primary server, you'll have a secondary server, and then you'll have a virtual IP that will be mainly held by the primary server. So in case the primary server falls down, or it just fails in your network, the secondary server will claim the virtual IP from the primary server, and it will start handling the DNS or DHCP traffic. So here, the main crucial information that you will be feeding in here will be the primary, secondary server, and you will be enabling it for DHCP v4, v6, or both the services. So here, you will be even for DNS service, you can enable it. I can show you a screenshot. We have it in our presentation. So basically, you can configure it for DNS and DHCP as well, and you'll be feeding in the virtual IP, and based on the heartbeats that the secondary server sends. So we have a special package called Keep Live D. So based on the special heartbeats that the secondary server sends to the primary server, in case the secondary server detects the messages are not returned from the primary server, it will sense that something's wrong with the primary server, and then it will take the virtual IP. So the DNS and DHCP clients that are querying or demanding leases from the DNS or DHCP server would not know the underlying server behind it, whether it is the primary or the secondary server. They just know the virtual IP. So it is only the virtual IP that is being displayed to them, but it could be the secondary server in case a failure occurs. So we would recommend the high availability setup when you are using DHCP v4 in unicast or multicast mode. In DHCP v4 broadcast mode, we would advise you to use DDI Central's built-in failover configuration rather than the HA setup, because when you set up HA in a broadcast mode, both the DHCP servers will be will come into the fore and start servicing the DHCP request from the clients, and this would lead to it will crumble down the network, as both the servers will be servicing the network, and it will give rise to several IP address conflicts. So in order to avoid those problems, we would recommend using DHCP HA setup only for DHCP v4 in unicast and multicast mode, and especially for DHCP v6. So let's get into the other modules in the settings. So once you have onboarded your servers and set up your high availability configurations, you can customize the configurations, like what should be the polling intervals, health polling intervals, DNS polling intervals, and everything. You can customize the polling intervals. You can set up the idle timeout and everything. So it's basically polling interval customization. So you can customize basic application settings over here, and then you should be onboarding your users here. So when you click on add user, you can enter all the essential information to identify a particular user, and you can also give them TOTP authentication, and the crucial part is assigning them a role. So we have 4 roles available in DDI Central, which is admin, operator, auditor, and guest. The auditor is meant for compliance teams who will be viewing only the audit logs available in DNS, DHCP, and the user audit logs. So they'll be viewing only the audit logs, whereas the guest role is for higher authorities or any other stakeholders who must be involved in just monitoring the configurations rather than not making any configurations to the changes. For that case, you can use the guest role. So they can just come as a viewer and log out as a viewer. That's it. They can't make any configuration changes, and it is the admin and the operator who will be making effective changes to the configuration. So admin do not have any restrictions at all, and it is the operator that you can make fine-grained control, set up fine-grained access policies for the operator. So basically for an operator, you'd be selecting the cluster they'll have access to and the type of services within the cluster they'll have access to. So when you open an operator, you'll see the cluster they've been given access to and the type of the services. By selecting DDI, you give all the services under the operator's access, and then you can choose within the DNS service, you can choose the zones that they'll have access to. So basically, you can limit their access footprint within your cluster. So that's how you add operators. And then you can also view their user audit logs when someone is logged in and logged out, all those for compliance and erecting the security posture of your infrastructure. And then the crucial part is configuring your SMTP host. Here you'll just click on configure SMTP and you can specify the protocol for authentication, and then you can specify the SMTP server details. And we offer two types of authentication. It's the basic traditional username and password based authentication, or you can go for OAuth based authentication. So we have two integrations with two providers, which is Microsoft Azure and Google. So you have integrations with these two providers. You can establish OAuth authentication with them, and this is only OAuth authentication is only available for SMTP authentication. So you can this is very crucial because DDI Central communicates all types of notifications through emails. So it's best if you configure the SMTP in the early stages of setting up the DDI Central, and all the alerts would be communicated through email or via in-app alerts that you get to see over here. So we'll be discussing in the further segments. So after setting up the SMTP, you'll set up login authentications for the users. So in order to simplify the login authentication, we have something called SAML, which is a single sign-on capability that we have integrations with 4 identity providers. So basically, you'll be registering DDI Central with renowned identity providers like Okta, Ping, OneLogin, and Microsoft Azure. So when you register DDI Central with these providers, the DDI Central users can use these identity providers for authenticating with DDI Central. So they don't have to have certain dedicated configurations, dedicated authentication credentials when they are logging into DDI Central. So so you can simplify the login process for them. And then you can also have a LDAP server onboarded. You can choose the protocol that you would be deploying, and based on this, the users can authenticate with the LDAP server, and they can easily get into DDI Central. And then you can create contact groups. So when you create a contact group, you'll be specifying all the members of the contact group and the clusters they'll be in they are associated with. So when you choose the clusters for a contact group, any events that are happening within the cluster, the email notifications that I talked about earlier will be communicated to only these members within the contact group. So if a contact group is created for a cluster, any events that are happening within the cluster will be communicated to only these members, not for all the users within DDI Central application. So this way you can send communication. You make sure the essential information reaches to the right users who have access to the cluster. And then we have the dashboard. Once your servers are onboarded, DDI Central will start discover the configurations, and any configurations that you make will be written permanently into the server. So it will start monitoring the services running within the server, and you can get the key performance stats over here. And then you can get it to the DNS module. So it's basically the DNS manager where you'll get to see all the discovered domains. In case you would skip discovery, you'd like to import new domains from an existing provider, or you have it in CSV format or in a zip format, you can just import those files into DDI Central using zip files. So you basically all the authoritative information, authoritative zones, authoritative domain names are being imported using the import button. So you can choose the server which is going to act as primary and secondary server for those domain names that you're going to import using the zip file. And you can while importing, you can select which view should act as custom view for serving custom responses. So you can choose the custom view over here. So you can start importing the domains using the import button. Or if you'd like to create domains one by one, just click on add domain, and you'll enter the all the domain relevant information like the name of the domain, the TTL values, the refresh retry intervals, and everything. The crucial part is here where you specify the type of the domain, where you'll specify whether it's an authoritative domain name or it's a forwarder. Suppose if you configure a forwarder, it will mainly redirect the traffic to an external DNS server. So basically, it forwards all the requests that come to a particular domain name to an external DNS server. So and then the next thing will be the response policy zone. So with response policy zone, you basically create custom responses for any publicly available domain name that is accessed through your network. So in case your resolver is supposed to resolve a particular public domain name, in that case, you can serve custom responses rather than making your resolver go through the actual recursion process. So it just helps you resolve internally to it helps you serve custom responses for your internal queries. So if you so this is very beneficial in case you are managing a close knit private network, and if you'd like your network users to not access certain public domains, and if you'd like to serve custom responses, you can very well use response policy zone. Let me show you how that is done in the further segments. So basically, you'll be creating response policy zone, and you can associate a view for it. And while creating a new domain, you can also assign certain DNS options for it. So DNS options are basically DNS settings or advanced configurations that you can assign for a particular domain that you're going to create. And you can specify whether this domain is going to be a dynamic DNS zone that is going to receive dynamic IP updates from your DHCP server. So if you enable that, you should specify the DHCP type associated with it, whether it's going to be a DHCP v4 server that is going to update the IP addresses for the domain, or the DHCP v6 server that is going to update the IPs for the domain. So these are the basic information that that DDI Central gets while creating a new domain. So once the domain is created, it is listed here in the domains page. So you can click through a domain name to access its records, and you can create, update, or make or delete these DNS records. So we have inbuilt validation rules here. So you can just state the name of the record, or you can set it on a schedule. So when you set it on a schedule, you specify the date and time upon which this specific record should be activated. So this is this is one of those automations that was meant for proactive network management. In case in a weekend your network administrator is required to create provision new networks or new DNS domain name for your network, they can easily set this up, schedule it, and forget it. So they can just state the date and time upon which the configuration has to be activated, and they can save the configuration. So on the set date and time, the particular record or particular domain name will be activated. So that's how records are accessed and records are updated. So when you open a domain name in DNS Manager, you can also sign sign that particular domain name. So we have the DNSSEC option over here. You can sign in your domains as and when required. You can also unsign them. So whenever you click on DNSSEC button and sign those sign a domain name, the following records will be created. Like it will create a DNS key and key signing keys. It will generate DS records and zone signing keys. This will be automatically generated, and this will help in DNS cache poisoning. Mm, and after DNSSEC, you have the import and export options. In case you would like to import records for a domain name, if you have so many records for a domain name, you can just import them using CSV, import them as bind, and you can export them as a text file. So that's how the record management is taken care of in DDI Central. And once you're done with the records and domains and domain names in the domains page, you can set up views for your domains. So views are custom responses that are served when a certain criteria is matched. So let's see how this is done. So in a view, you just name a view and you specify the match clients. The match clients can be an access control list or any specific IP address. So if you specify any, it can be any client. And if you specify any client in particular via the IP address, it will make sure that whenever a particular client accesses a particular queries for a domain name, and if there is any view associated with the domain name and with the certain IP address, it will make sure that the view is served instead of the original response configured in the under the domain name. So here you'll be creating any access control list rather than specifying one by one IP address one by one. You can assign a DNS option for access control list. You can create it like that, or you can specify the named access control list in the list over here. And then that's how the views are created. So once you're done with the views, you can view the audit logs for each managed DNS object, whether be it a particular domain name or a particular record. You can see who has done what in the audit logs. You can customize the timeline and you can file them for compliance. So you can see all the audit logs with great visuals, and you can export them as filter them out for a particular timeline, and then you can export them as a CSV file or a PDF file. So we have the analytics model over here. Here it captures key performance metrics of all the domains within your infrastructure. So the DNS manager within DDI Central captures DNS analytics for all the hosted domains within your Linux-based servers and all the blocked domains blocked via DNS firewall and all your non-hosted public domains that you access via your infrastructure. So any queries that you make through your DNS resolver is being captured under this analytics tool. So you can view the analytics for each all those domains. So when you click through a domain name, you'll view the similar stats like queries per second, total queries, the hourly query load, and also see what all the IPs that have been accessing a particular domain name and how many queries they've been made in total. And the visual donut plot will give you quick visual snapshots of the IP addresses and the number of queries they've made for a particular domain name and the type of records they've been accessing. All those have been will be captured in analytics module. So the other type of information that will be captured will be the response code analytics. So in DDI Central, we also capture the type of responses that is being delivered after a successful query. We also capture that, and we also make sure that it's listed in the analytics page. So once you've seen all those information, you can export them as a CSV file or a PDF file. And so when you get out of this module, you'll have something called search by IP. So you have a certain IP in your network infrastructure, and you would like to see the DNS footprint, the DNS access footprint, query footprint of a particular IP. So in this case, you can search for a specific IP. So when you enter a particular IP, it will show you the whole list of domains that a particular IP has been querying within your network. So by clicking on each domain name that is being listed under that particular IP, you'll be able to track out the whole DNS footprint of the IP in your infrastructure. So that's about the DNS query analytics. And then we have the config part. Here comes the advanced configurations that you can set up for the whole cluster. All the configurations that you see over here is meant for the whole cluster. So any option that you set over here will be meant for all the domains in your infrastructure, in the cluster, rather than for a particular domain. The DNS options that you saw under a domain name is limited to that domain name alone, but here it's meant for all the domain names. And here you'll have the DNS firewall policies, wherein you can block certain domains. In case if you have a set of suspicious domains, so it's basically like a static block list. So you will get a certain, if you have certain suspicious domain names, or if you, under your corporate policy, if you'd like to block certain domain names, you can just feed them one by one, and you can block all the subdomains in case you're not sure about what all the subdomains exist under that domain name. And you can assign a particular category, custom category that you'd like to create, or you can view our custom list. You can import them depending upon your industry, and you can put them into your block list. Or you can, if you have certain list of domains that you'd like to block, you can import them as a CSV file. So you can import them in bulk over here rather than adding one by one. And the crucial part here is you give a redirection IP. So whenever a user from your network infrastructure is trying to access any one of the domains that is a part of the block list, they'll be redirected to a particular IP. So the IP that you give over here. So that's how the malicious domains for recognized malicious domain names are blocked in DDI Central. But if you are not sure if the domain names appear to be genuine ones, but they are inundating your DNS servers with overwhelming DNS query traffic, we have something called the rate limiter. So you can search for the rate limiter. So it will basically ask for certain configurations, like you can tell how many identical responses are allowed per second, and how many errors are allowed per second. You can specify, you can exempt few trusted clients from truncating it will basically truncate the response. So you can exempt certain trusted clients from this, from truncating the DNS response. And you can specify the slip rate. So basically the slip rate, what it does is it truncates every nth response. So if you specify the slip rate as 2, every second response, or every response, every 1 in 2 responses would be truncated. And you can specify a time window. Like if you specify the time window as 5 seconds, for every 5 seconds, every 2 identity based on the slip value, every 1 in 2 responses within the 5-second window will be truncated. So you can basically combine all these configurations together, and you can create a fine-grained policy for truncating highly highly amplified DNS attacks like the DDoS attack. And you can create named access control lists. This will be very essential when you create views. So you'll just basically specify, if you're very well versed with bash programming or ISE format, you can very well do it. Or you can just choose our template format, where you'll be specifying the allow and deny list. And you'll specify if if at all you're allowing certain clients and if you'd like some secure authentication to take place, you can choose the keys. These keys are nothing but transaction signature keys, which I'll be covering next. So we all we do is create the keys separately, and here you'll be just selecting the names of the keys. So basically, you'll just have to select the name of the key that you'd like to deploy, and then you can save the configuration. So for the TSIG keys, you'll be creating a named TSIG key specifying the algorithm that you'd like to deploy in action. And then based on that, the secret key will be generated. So once you create a TSIG key, all you have to do is make sure that you mention, select the TSIG key name by its name. And that's how you put it into action. So whether be it for DDNS transactions, the dynamic IP updates, you can use these TSIG keys, or for an access control list, you can also deploy this TSIG key. And then we have the scavenging process. This is a maintenance procedure actually. If you have certain, if your DNS infrastructure is accumulated with a lot many records that you like to keep them up to date, you can specify an aging criteria. So here you configure the criteria. So you tell DDI Central the scavenging period, which is basically the aging criteria. For 30 days, if a certain DNS record does not respond, that is considered a stale record. And for TXT records in particular, you can specify specific aging criteria, and then you can schedule this on a certain frequency. Like if you would want this process to take place every week or every month, you can just schedule the interval, and then you can specify the domains that will be subjected to this scavenging process. Whether so the domains you choose will only be subjected to the scavenging process, or if you would like to list out all the domains here, you'll have to specify the domain names one by one, and then you can save the configurations. So when you have set the scavenging process on schedule, it will make sure for the frequency that you've chosen in the configuration part, it will display all those stale records over here. Here you can reclaim them or purge them altogether. And if you are not sure about the scheduling process, if you'd like to scavenge it right now, you can just click on scavenge now, and it will initiate the scavenging process right away. So in that period of time, at that current point of time, whatever stale records that are present will be listed out in the scavenging report, and based on that, you can reclaim it or purge it. So that's about scavenging. And then all the configurations in the scheduled module, all the configurations that were set on schedule will be displayed, and you can just delete these configurations that were set on schedule, or you can reschedule them. So if a configuration is set for schedule on a future date or time, you cannot make any amends to the configurations that were set on schedule. So you cannot make any changes basically to the contents of the schedule. So if I've set a record on schedule, I cannot make any changes to the record that is subjected to the scheduling process, but I can change the schedule. So I'll be able to only view the records, but I cannot make any changes to it, but I can reschedule it or delete it altogether and make the necessary configurations and then schedule it once again. So that's how the scheduling process takes place, and this is where you make amends to the schedule, and you can also view the status of the schedule. And for the reports, the DNS report will have the query analytics information, so you can generate reports for all the domains in your infrastructure or for select domains in your cluster. And then so when you configure a certain report, you will specify its frequency, and you will tell how many versions of the reports that you'd like to retain within the application. So if you specify 5 over here, the latest 5 DNS query reports, if based on the frequency that you've chosen, will be retained within the application. So with these retained reports, you can compare and analyze and make the necessary decisions. So you'll have time to time updates about your DNS infrastructure for a certain cluster within the application. So that's about the records. So that's about the DNS manager module. And then let's quickly dive into the DHCP module. Here, this is called the DHCP scope manager. So here you'll be able to control your scopes. So you have the IP address, which on an atomic level cannot be divided at all. So this is the atomic level of division in your IP network. And then when a range of IP addresses are put together, we call it as subnet. And these are the basic building blocks of your network. So in order to create a subnet, you just create or click on add subnet, mention the network address and mention the network prefix. So let me open a subnet in edit mode, so you'll have a better idea. So you specify the prefix and you assign a DHCP server that will be able to provision IP address server. So basically you give the authority to a DHCP server to provision IP address from this particular subnet. So if you want it in on a failover mode, so if you see that this DHCP server is not promising and if you'd like to have it on a failover mode where you assign two DHCP servers, primary and secondary DHCP server. Let me show you in further segments how a failover configuration is created. All you have to do is enable the failover DHCP configuration and select the failover configuration by its name. Yeah, it's just that simple. So all the configuration will be done in the configuration part, and all you have to do is choose by its name. And for each subnet that you create, you can hierarchically organize your network in this tree view. So if you choose a subnet to be under a global level is nothing but standalone subnets. So if you want your subnet to be a standalone subnet that is always at the top level, that is not under any some shared network or any other element, any other scope, you can just put it on the global level. Or if it's under a shared network is nothing but a bunch of subnets put together. So if you'd like to accommodate your subnet under a particular shared network, you can very well do it, or you can keep them as a standalone subnets under the subnet category. So if you, so depending on your requirements, you can create your subnet or you can schedule your subnet just like how you scheduled a DNS record. Or if you'd like to recognize, if you have a complex IP infrastructure, if you'd like to hierarchically organize your network, you can put a subnet under a particular supernet. So we help you create nested supernets when you are organizing your network. So a supernet can be nested within a supernet, just like the ones shown over here. So you can assign the subnet under a supernet. Make sure that the supernet has a bigger network prefix. And you can also assign an exclusion range within a subnet. So within this exclusion range, you can specify the from and the to IP address. So within this range, the DHCP server will make sure that it never touches this particular IP range. And you can create VLAN atop this subnet. Just you'll have to create a new VLAN, just specify the VLAN details, or you can assign it to an existing VLAN. So that's how VLAN is created. You can just associate it with an existing VLAN, or you can create a new VLAN by specifying its VLAN name and VLAN ID. And the crucial part over in a subnet is that a subnet can have different IP pool ranges accommodating different clients. So in order to distinguish what clients should occupy different IP addresses within the subnet, we declare the pool data. We declare a particular address range and we assign something called client class to it. Client class basically identifies a group of clients and makes sure that certain clients get certain IP addresses, a dedicated IP addresses from a dedicated pool. So it's basically telling the DHCP server that if you find out certain clients, make sure that they get IP addresses from a dedicated range. So that's how you set up a DHCP fingerprinting policies. That's basically recognizing your client and automating the IP assignments for them. So for this, you'll have to declare your IP address range. So we'll open this pool in edit mode. So you basically defined a range, and then you'll have this allow deny setup where you specify the client class that should be allowed for this particular range. And if you have certain clients that should never be provisioned IP addresses from the following range, you choose no, or you just choose none of the client classes will be applied for this particular range. So if you have certain requirements in particular, so a particular segment of IP addresses should be dedicated for, say, iPhones in your network, so you can just declare the range and assign the client class, associate the client class that was meant for identifying the iPhones in your network. Let me show a client class by showing the client class that was created for Pixie clients. So when you create a pool, you can assign DHCP options that are exclusive for a particular pool. So you can create DHCP, select certain DHCP options for it, or you can create new custom options. You cannot create custom option here. It's available in the config module. All you have to do is select the name, select the custom option by its name over here. So the creation process lies in the config module, but you'll be only selecting the custom option by its name and specifying the value for the custom option. That's it. And you'll save the configurations. That's how the subnet will be configured. And if you would like to assign certain DHCP options on a subnet level, you can very well do it by using the DHCP options and custom options. So for example, this will come into action when you have a DDNS domain. So in case you have defined enabled DDNS for a particular domain name, and if you'd like to update IP addresses for the DDNS zone from a certain subnet, if you're very specific about IP addresses for the DNS zone to be provisioned from a particular subnet, make sure that you navigate to the DHCP option and then select the DNS relevant options. Like you have there are 3 mandatory options. So whenever you activate the DNS toggle for a particular domain name, the following 3 options will be enabled, automatically created, like DNS updates, which will activate the DNS dynamic IP updates for the particular for a particular subnet. And then it's basically instructing the DHCP server that make sure that this subnet should provide dynamic IPs to a particular domain name. And the next step would be how the updates should happen. So first you allow the updates, and then next you specify the style of updates. For the style of updates, we have only one option, which is called interim. So when you choose interim, it basically makes sure the transaction is secure. When the transaction is secure, we mean by using TCP keys. So whenever you're making DDNS, when you are activating DDNS for a particular domain name, make sure that a particular TCP key is also chosen to have secure transactions between the DNS and the DHCP server. So the next option would be choosing the DNS domain name. So for which domain name this updates should happen. So that can be specified under a particular subnet. So if you're very particular about a certain subnet provisioning IP addresses for a domain name, make sure that you specify the domain name under a particular subnet level. So that's how you customize DNS for a particular subnet. So let's see how client classes are created. Now, for the client class, we'll take the Pixie boot client class. So whenever you create a client class, make sure you name it well with the specific purpose in mind, and you'll be assigning it on a global level, or you'll be assigning it under a subnet. And then if you declared the pool under a particular subnet, that's fine, or you can mention the pool that you're interested by selecting the range of the pool here. And the same allow deny setup will be available here, whether you're going to allow a certain client for a particular range, or you would like to avoid the client class for a particular range. So you just mentioned the setup over here, and you can also schedule a client class, and then you choose the template type rather than the ISC format. So if you're an expert in ISC formats, you can just give them an ISC formats, or you can just choose the template type, and you can enter the values for the template. So if you have, we have a Pixie boot template that we have some templates for just like ACLs and TC keys. We also have templates for Pixie boot. So you can just choose the template type, and you can import the values from the template that you've chosen, choose it by its name. Or if you do not want any templates to be associated with the client class, just mention the how the DHCP packet should be passed. So basically, you're getting the information where how the DHCP packet information from the client has to be passed. So if it is a Pixie client, if it's a bare metal server that has no boot file in it, it will come with the DHCP message that it's a Pixie client. So it basically says to the DHCP server that it does not have any boot file and it needs a network level booting. So it will come with the message Pixie client. So when it detects the match value in the DHCP packet, it makes sure that it passes through the DHCP packet. It searches for a substring. So you can specify any match value. In this case, we are searching for a substring, and you mentioned the offset and the length value. And here you instruct the DHCP server to get through the options area where you find the option vendor class identifier. So if the vendor class identifier option has a certain value, so this recognizes that it is of certain architecture. In this case, it is a CentOS 7 architecture, and you give the file name, the boot file that should be fed to the Pixie client. So when this criteria is matched, the client would be directed to the TFTP server that is mentioned using the option called next server. It basically directs the Pixie client to a TFTP server of the said IP, and there the Pixie client will get the boot file path, will get the boot file through the following path. So that's how you can effectively distribute Pixie files on your network through the client class. In this case, you can also assign certain DHCP options which are limited to this client class alone. So any client that satisfies this criteria will be assigned the DHCP options that come along with it, or you can create a new custom option. So that's how the client classes are configured. And then we create another scope called shared networks. Shared networks are a group of subnets bunched together, and you can treat them as a single entity, and you can assign DHCP options and custom options. So all these subnets will be considered as a collective unit, and all the DHCP options that you choose over here will be collectively applied to all the constituent subnets. So you can also set them on a schedule. And then we have VLANs. VLANs are basically built on the top of subnets. So basically you will just select the subnet that will be associated with the VLAN and give the VLAN identification details like its name, ID, and everything. And that's how VLANs are created. VLANs can be created under for a subnet or a static subnet. So this way, it will have isolated broadcast medium with the DHCP server. Instead of communicating on a broadcast mode that combines with the broadcast traffic with other clients. So when you put a certain VLAN, certain clients in a VLAN, the clients will have isolated broadcast mode. So they will be completely isolated from the other network clients. And then you can create a supernet just for organizing your subnets in a hierarchical order. So you basically specify the network address of a higher address space, and then higher prefix, and then associate the subnets under it. Or you can nest other supernets, other lower supernets within it. So you have a beautiful hierarchical structure for your complex network infrastructure, for your complex IP infrastructure. So that's how the supernets are created. In case you have certain delegated scopes, certain critical devices that you would not want the DHCP server to interfere, and you would like to manually provision static IPs to it, you can very well do it, or the industry calls it delegated scopes. In that case, you can define the static subnet limits. The DHCP server will not interfere with it. So you just have to mention the network address of the static subnet, and the static subnet will be automatically created. In case you cannot create a static subnet and you only have the static leases associated with certain devices, so if you have them in a CSV format, you can import those static leases in here. Then DDI Central will automatically create the static subnets when you mention the static leases under concern. So it will, if your static lease is created for an address, say 1.1.1.1, it will create 1.1.1.4. It will create a subnet, a static subnet automatically, and the whole subnet will not be under the influence of the DHCP server. So that's about the static subnets. And then if you've missed activating the DDNS option in the DNS module, you can directly come into the DHCP module and add a domain. Just specify the domain name and specify the TCP key for carrying out the DDNS updates in a secure manner. And you can also create DHCP reservations using the host configuration. Host configuration is nothing but DHCP reservation. Here you'll be mentioning the name of the host, and assigning the MAC address of the host and specifying the fixed address to be associated with the particular host, and then assigning it under your network hierarchy, whether it's going to be on a standalone mode or it's going to be under subnet, shared network, or under host group. Host group is nothing but a bunch of hosts put together, so you can manage it under a host group. So you can treat them as a single entity and assign collective policies to them. And you can also set a DHCP reservation on a schedule and assign DHCP options and custom options for a host, for a particular host. So these options that you set over here will be applicable only for a certain host, and the ones that you set for a host group would be collectively applied for all the hosts within the host group. So that's about the DHCP scopes in DDI Central, and audit logs are captured for all the objects managed by the DHCP server, whether be it a pool data or client class or host group. Everything who's done what is documented, and the audit trails are completely captured over here. So this can be used for compliance purposes. And then we have extended DHCP configurations, and here is where you configure the DHCP failover configuration. You name the failover configuration, specify which DHCP server is going to act as the primary and the secondary, and then give all the associated port details. And here comes the crucial part where it is the split value. So a split value here as 128 would get the DHCP servers in a 50-50 load balancing mode, where both the servers will be receiving traffic from the DHCP clients, and they'll be serving the traffic in a parallelly in a network. And you can customize their response and their updates. So you can just configure them, and you can save the configuration. So the failover configuration that you select over here will be associated with a particular subnet rather than the whole DHCP server, just like how we saw in the HA setup. HA setup is meant for the whole servers in your infrastructure, but with the failover configuration, you create a configuration, failover configuration, and then associate it with a particular subnet. So this is the one that will ensure reliability or continuity in DHCP service traffic when a primary DHCP server fails. So if you're handling DHCP v4 in a broadcast mode, this is the only option available to ensure that the DHCP traffic is the DHCP services are always uptime. So in order to ensure the uptime, you just have to configure the DHCP failover configuration. This is a built-in configuration within DDI Central. So make sure that you assign this failover configuration for the subnet that is being broadcasted on a that is set on a DHCP v4 broadcast mode. And then the options, DHCP options that you set over here is meant for universally for all the clients rather than a set of clients. So these are called the global options. These are aggregated from all the servers that you onboard in a cluster, and then it is maintained as one single aggregated list of options. So if there are any overlapping options, the latest onboarded server's configuration option value will be taken as the option for the cluster. And you can create custom options only here. So just get into the config module and create a custom option. So once you create a custom option, you'll have to mention the data type for the custom option and then specify a code value. You can use an already existing space or you can create a new option space. This is essential, and make sure you name the custom option driven by its purpose. And then that's all about the custom options. For templates, we only offer Pixie Boot templates, and many other templates are being developed as we speak. So that's about the whole DHCP scopes and configurations. And when it comes to schedule, you can see all the schedule configurations. Here you can set them on a reschedule, or you can delete them. And you can also see the status of the schedules. And then for the reports, the content in the report would be the subnets IP utilization capacity. So that will be highlighted in the DHCP subnet report. So you can configure this for all the subnets in the report, or all the subnets in the cluster, or you can just select certain subnets and you can generate scheduled reports for them. So basically you'll be mentioning the scheduled period, and then how many versions of the reports that you'd like to retain. So based on, so when you choose 5 or 3 latest reports, you can see from time to time how your subnet has been utilized and see if the utilization is nearing exhaustion or something. So this will help admin to see if the performance or the utilization thresholds, to monitor the utilization thresholds of a particular subnet or the whole set of subnets within a cluster. And then let's quickly dive into the IPAM module. So the key performance of the IPs will be listed out in the IPAM dashboard. So this will give you the total subnet usage of a particular cluster and the top utilized subnets within the cluster and the whole device profile associated with a particular cluster and the IP usage within the cluster. So how many available IPs are there, and how many active IPs are there, and how many fixed IPs are there. So it basically gives you the essential availability stats of the IPs within the cluster. And when you get into the lease module, you'll get to see the DHCP leases that has been actively leased. And when you click on a particular IP within the DHCP lease, it will show you how the lease has evolved over time. So basically there are some sections missing over here, which I can show it in the presentation. So when you get to view the DHCP lease, it basically shows the summary of an IP. So it will show you the DNS records that has been associated with a particular IP over time, and it will show how the IP has evolved over time. So this will show you for this particular lease time, this MAC address was associated with the particular IP. So this lease history analysis is needed if you are ejecting and replacing a particular server within your network. So this will help you backtrack all those connections associated with a particular server or an important critical machine within your network. And then you can see the whole DNS footprint of a particular IP. So using this IP, if my clients in the network have made certain DNS queries, and if they've been querying certain domain names, all those queries will be listed over here. All those domain names will be listed over here. And what are all the domain names that have been that they have been accessing using the particular IP is listed over here. And then it will show the total queries made to that particular domain names. And this is shown in a visual graph plot. So you can customize the time window, and you can see the query load being the query load that this IP has been doing in your cluster. So the device profile assigned will be the cumulative devices that have been associated with a particular IP over time. So you can have a colorful donut plot that will show the type of devices that a particular IP has been associated with. And that's about the DHCP leases. And we have an interesting addition over here. We have something called a new integration that was introduced last month, which is our integration with Endpoint Central. So far you've seen how how the DHCP lease mentions the IP address of the lease, the IP address that is being leased, and to which host it has been leased, and everything. So this is what traditional IPAM tools do. So an added advantage for DDI Central's IPAM is it not only mentions who's behind a particular IP and what device is is behind a particular IP, but also mentions how secure the devices and how vulnerable the devices. So you basically get all the device-based information and also the system details of that particular device, and also the admin will be able to quickly visualize what are the missing patches within the device, and also see the vulnerabilities associated with the device. So based on the CVSS 2 and CVSS 3 scores, you'll be able to see the severity of the vulnerabilities within your machine. Suppose if a particular particular host has been accessing malicious domain constantly, and this has been pointed out in your analytics page or via the email alerts or via in-app alerts, you will that the particular device, something's wrong with the particular device. In order to confirm if the device is actually risky or not, you will get into the lease details, you'll drill down the lease further, and you can see how the real status of the risk within the device. So you can, based on the severity of the vulnerabilities, you can isolate the device and from your network, and you can quarantine them immediately. So this gives an added value for network administrators. They can easily identify the device and isolate them from the network. So this is very essential when you're dealing with infected endpoints. So for this, you'll need to have Endpoint Central subscription. With that subscription, you can integrate easily with DDI Central, and you can have effective visual insights within DDI Central. So that's about the DHCP leases. And when you have the static leases imported, we just do not just capture the subnet usage and the static lease usage details. We just ping those static subnets to see if the device actually responds or not. So based on our ICMP pings, we make sure we inform the network administrator that the particular device is down. So we just do not display the information in the DDI Central UI. We take accountability for its status, and we make sure that the admins are informed of the device's status, whether it's active or inactive, to the admin. So we just do not have do not let we do not just we take the accountability. In many softwares today, they do not take accountability about on of the delegated scopes, but in DDI Central we take accountability about the status of the devices, whether it's reaching out, whether we are able to reach out or not. We just inform the network administrator. This helps the network administrator even if they are manually managing it. This is an added valuable information for the network administrator who might have many other important assignments. So this way they can manage critical devices and attend to those devices on time. So you can have hands-on control over VLAN IP address inventory. Just get into the VLAN menu. You can click on VLAN and just get into its IP inventory. So you can just see the host assigned for a particular IP, and then you can see you can ping it, and you can use telnet based troubleshooting protocols to test those IPs on a custom port number, and then you can see if there is any DNS relations associated with a particular IP in a VLAN, and the same is applicable for the subnets. So just choose the subnet of your choice, and then you can have hands-on control over the IPv4 and IPv6 inventory of a particular subnet. So so just choose the IPv4 subnet that you'd like to consider, and then you can see the availability states of the IPs within the subnet. So you can click on if there is an issue, if there is a user that's unable to join a network. In that case, you do not have to keep the user in waiting. You can just click on an IP address, available or free IP address, and then assign it to that particular user. So just clicking on it will take you to the DHCP reservation page, where you can assign the IP address that you just clicked on, and assign the MAC address of the user who is unable to join the network, and then you can onboard them into your network without wasting any time, and they can just get quickly onboarded into the network. And meanwhile, the network administrator can troubleshoot what's wrong with their with the obstruction of the DHCP lease or anything. So in this case, you can have hands-on control over the IP address inventory, or if you'd like to have some monitoring procedures involved, if you'd like to know what are the DNS relations involved, you can just click on the DNS relation to see the DNS relations associated, DNS records associated with a particular IP under the subnet, and then you can see the host or MAC address associated. If it's an active lease and you would like to know who's behind a particular lease, you can just click over here and see the MAC address associated with a particular IP. And I have a certain slide for it. Let me just show you. So if you choose DNS relation, you can see the records associated with the particular IP. So that's how we bring in effective correlations between IP, DNS, and MAC addresses of a particular host. So this way you have we bring about data, we triangulate the data from all the sources and make sure that rich contextualizations are derived for the network administrator to troubleshoot your network and have easy visibility and control over your network hosts. And then we have the alerts module, where it will alert the network administrators via email or via in-app messages. So you will have certain key events. We have these many key events. So whenever these event happens, it will be the network administrators are officially informed within the app as notifications, or in the alerts page, or via emails. And then we have an interesting type of cluster that was added in this release, which is the cloud observability cluster. So this is an era where we manage hybrid assets, be it on-prem or on cloud, we manage both. So in order to have a unified visibility for the network administrators, we have made sure that all those native cloud assets are brought into DDI Central so that the admin manages them through a single interface. So in case you have, so we have multi-vendor DNS integrations with AWS Route 53, AWS Route 53, Microsoft Azure, Google Cloud DNS, and Cloudflare. So basically what we do is migrate the zones that we have that you have with these providers. So basically you will create a provider profile and you will enter your account's credentials, and based on the domains you host in with that account, all the domains will be discovered, and based on that you can choose what are all the domains that you'd like to migrate. So we offer you hands-on control over the records of these migrated zones. So these are considered licensed items. So when you migrate around 20 zones, make sure that you have enough provisions to add 20 zones. So if you're subscribed to one of our plans, and if you have only provisions to add around 15 zones, and if you've already discovered or added 15 zones into your on-prem servers, make sure that you add purchase more zones as add-ons and migrate those zones. So without the zones, additional zones purchased, you cannot migrate them. So once you migrate them into DDI Central, you will have effective control over them. So just like how you manage the DNS records of your hosted domains, you can also have control over those cloud providers zones. So be it any cloud provider, be it AWS or Route 53 or Cloudflare, you can just have control over them, how the records are being managed, and you can also create new domain names. So whenever you create a domain name, there'll be a two-way synchronization. Be it so when any changes that you make to a domain record or a new you create a new domain name, it will be reflected with your cloud provider's infrastructure. So we basically offer two-way synchronization, and that's why we license each and every zone that you migrate within DDI Central. When it comes to the domain names, we also capture the audit logs for the domains that you migrate within DDI Central, and we also offer you help you monitor the key network assets, cloud native network assets with AWS. These assets are VPCs and their subnets, EC2, ECS, and RDS workloads. So if you'd like to visualize these particular network assets within DDI Central, you can very well do it. Let me show you in. So for that, we will have to create a special type of cluster called Cloud Observability Cluster, and you need to create a provider profile for that. So you'll mention the name of the provider. In case if it's AWS, you'll mention the type of the services that you'd like to access. If you'd like to monitor all the services, you'll have to mention all the services you'd like to monitor, and then you can see the visualizations for it. So whether be it VPCs, EC2, it'll connect with your account, and you'll be able to visualize them through DDI Central's unified interface. So if you'd like to see the EC2 instances or VPC instances for a particular in your AWS account, you can see in what all regions it's been distributed. So you can see how it is being distributed all throughout the globe, and then based on the service of your interest, you can just select the type of the service, and you can have a global visibility of their availability in different global availability zones. So you can see in what are all countries this particular VPC and subnets are available. So you can just have an quick visual snapshots of their availability in around the globe, and you can see the top 5 utilized subnets, underutilized subnets, and the subnet states, and the EC2 instances states. So this gives you the vitals in your AWS network, cloud native network assets. And then when you get into the VPC module, you'll get to see visualizations limited to VPCs around the particular availability zone. For this, you'll have to choose the particular availability zone, and based on the availability zone chosen, the VPC's availability will be visualized over here, and you can choose and how it's being distributed across different cities within the zone. So in APAC region, so these are all the cities within the APAC region that the VPCs are distributed, and you can see for the particular availability zone, you can see the VPC states, whether it's available or on a pending status. And then if you'd like to see the whole IP address footprint, you can just get into the a particular VPC and correlate against a particular subnet, EC2 instance, EC2 network interface, load balancers, DB instance, and see the associated tags with a particular VPC. So that's how DDI Central gives you effective correlations for different cloud native network assets of AWS. So even for subnets, you can view all those correlations, and then so this way the network administrator has complete visibility over the IP and DNS resources of the cloud native network assets of AWS. So they'll have a unified visibility over their cloud assets as well as their on-prem assets. So when it comes to ECS, you can see the task definitions, and you can monitor the task status. So you can just get into a particular task, and then you can see its CPU usage and memory usage, and then you can see the container status and everything. So yeah, that's about the AWS Cloud Observability Model. So we are planning to bring more cloud native support for more cloud native assets, like you can see it in our roadmap. So we have introduced AWS for now, but we'll be introducing support for Microsoft Azure cloud assets and Google cloud assets. So GCP cloud assets will also be available within DDI Central in the near future. So it's been scheduled for release in the fourth quarter. And we are also integrating with Microsoft ManageEngine Op Manager and Mobile Device Manager Plus. And we are also bringing in more advanced threat intelligence. So we've seen only the static feeds for now, but we'll make sure that the dynamic, actively growing threat feeds are imported into DDI Central, are integrated into DDI Central rather than importing it for once. So we'll have growing threat feeds within DDI Central. So any newly created threat would be considered under DDI Central and blocked right away. And then for the DHCP services managed in switches and firewalls, yes, we manage them as well, and we are actively working on it. So that's the roadmap for 2025. It's quite an eventful year. Please watch out our space. Stay tuned for the updates that we provide. So that's about DDI Central. Thank you for taking the time to be part of this webinar. We hope this webinar has been both informative and transformative. If you have any further questions or would like to continue the conversation about how DDI Central can benefit your organization, our team is here to help. Here's a support email ID, ddi-support@manageengine.com. This is your host, Akshara, signing off. Thank you.